In this problem, we are given a root of a BST and an integer val. Our task is to find the node of the BST that contains the target val and return the subtree rooted with that node. If that node doesn't exist, then we'll return null. And how I went about this is that first I checked if the root itself was null, and if that's the case, we can return root, which would be null. And then I also checked if the root itself contained the target value on line 20, and thus we could instantly return the root. And this would be the best case, and would be done in O of 1 time complexity, as it would be in the first root, and we could instantly return. Otherwise, we would have to recur, and in order to do this, I have an if statement, root.val greater than val. And because in a BST, we know that a root has two children, a left node and a right node. We know that the left child is less than the parent node, and we know that the right child is greater than the parent node. And so this if statement checks that if the value is less than the parent root's value, then we know that the node containing the target value would be in the left child subtree. Thus, after this if statement, we have return search BST root.left val, which is when we make our recursive call. Otherwise, we know that the target node with the target value would be in the right child, and we can return search BST root.right value. And for the time complexity of this problem, as previously stated, the best case would be O of 1 when the overall root contains the target value. And in the worst case / average case, it would be O log of n when the overall root does not contain the target value, because when that's the case, we have to make recursive calls. And at each recursive call, we would essentially be cutting the input data in half. And that's why it would be O log of n. However, if the BST is arranged in either ascending or descending order, sort of visually like a linked list, where we have the overall root, and then it consistently has left child, another left child, another left child, or overall root, right child, right child, right child, in that case, it would be O of n, because it would have to consistently check each node and can't cut any of the data in half.